So, off to the next hands-on on automated data science in TabPFN. And as Frank talked about in the morning session, this is focused on tabular data, which looks like these Excel sheets. And for example, in this example, we would like to predict for individual whether the reaction to a drug is positive or negative, right? And this would be a very typical tabular data example. Now, in the specific hands-on, what we want to talk about is twofold, so automated data science, and I will explain in a second what that might mean, and then a bit more about TabPFN and that you can play around with the newest version that we have. And essentially, I want to first present to you a concept and vision for both of these cases so that you are familiar with what we mean. And then we will have hands-on for both, which basically a subfield of automated data science, which is using large language models or something like ChatGPT for feature engineering in tabular data, and using TabPFN with Batman, and you will see in a second what that means. All right, so let's jump right into it. And my time schedule is around 10 minutes for the start, and then, for the rest of the time, up to 50 minutes for these hands-ons. All right, so I will give you a motivating example that is very recent. I will talk about a Kaggle competition. So Kaggle is a website for data science where people regularly host competitions, and then a lot of practitioners start to try to solve this as good as possible. And over the last 5 months, there were regular competitions which we participated in. And this is one from the 1st of August, where you were supposed to predict poisonous mushrooms. It was simply, again, a tabular data challenge. And here, this is what the data looks like. So it's, again, one of these tables, and you have all these informations, and yada, yada, yada. And you want to predict a binary classification task. And the thing I want to basically tell you is that this was very accurately solved almost automatically by an LLM agent. So the second place in this competition was fully automated by an LLM agent. This sounds very awesome, and I think it also was very awesome because the first place, that was us, and we took 12 hours to beat them. We had 24 hours in total, so they took like 4 hours automated, and it took us 12 hours of very hard expert engineering to be, I don't know, a percentile better. It is the same score, but you can't see it. So that's where we are. It's a bit biased because this LLM agent specifically is very, very tuned for Kaggle, so it just knows how Kaggle works, it can do that. And in the backend, it just runs AutoML, so it's really about using the right combination of tools and making it work. So it's not a general purpose agent, we can't really employ it in the wild, but it's nevertheless very cool that it can already do these things. And the long story that you would like to have is that we go in this direction of an automated scientist. There's this recent paper by Sakane AI, which basically presents this idea that, we can just make an LLM do all of these things in this plot, which looks like a lot of things. And it suddenly can do all of these things automatically, do your experiments, write your paper and everything. And again, I'm not saying that this works in the wild. I think this has the same problem as the Kaggle example. But at least it's a nice idea, and specifically here, the last part is actually working very well. Also, maybe one more comment. For these Kaggle competitions, you see also more and more people actually using LLMs for feature engineering. So you regularly see in the discussions, which you can see here at the top, this discussion thing, that people just post what they found when they were talking to ChatGPT, and I also have a manual example for that. But generally speaking, the vision for automated data science is not a one-liner that does everything for you, but actually an assistant, a tool that you can talk to, right, really human in the loop. And an example would be in this case that, right, what I think is really often a problem in applications is like the question, what metric should I use? And the data scientist or the automated data science agent should be able to guide you through a process to come to a conclusion that tells you what you should do and which metric you should use. And this should go in the direction of, okay, what do you actually care about in your data? What do you actually want to predict? And this tells you what you should use. Similar, it should help you to run all of these experiments because it's actually a large pain to run stuff on hardware and distribute it across the cloud or whatever. And if we could just automate all of this, and it's very feasible by just using plugins like ChatGPT already uses to do this. So that's also a very cool application. And another one is, right, how should I pre-process my data? Talking about data essentially with an LLM or with an agent. And it really tells you, okay, you should use this transformation and you should be careful of this thing in your data. And it should be able to do all of these things, again, because it really just needs to act as an intermediary for a lot of the tools we already have. And finally, it also should talk to you in the other direction and notify you about problems in your data, right? We have checks that can tell us that your data might be biased or unfair, and the LLM could explain to you why and really explain to you how it should go. And this is the long-term vision that we hope to be at some point. And the thing I really focus on the hands-on today is this part about using LLMs for data engineering or feature engineering, because that is absolutely possible already. And that's really something, if you have never done it before, I can suggest you to just really use ChatGPT and try it out, because it works. All right, so giving you a manual example from this Monday, where the latest competition was, where we had to predict used car prices. And I have no ideas of used cars, especially not in the US. So what I just did is I said, here's a list of names of brands, like Tesla and co. Please give me where like the continent and state they come from. And ChatGPT, okay, I had to try ChatGPT Plus, but it basically gave me the list, a mapping, a dictionary mapping that I can just copy paste into my code in Python. Right? And this is like feature engineering that would have took me manually probably hours, or I would have not done it because like I would have been too lazy probably. And similarly, the right side is even more interesting in my opinion. So the task was to predict used car prices, and we had the name of the car. And I was like, okay, where can I find the average price for this specific type of car in the internet? And I looked around, it was really annoying to do. So what I just did, I asked ChatGPT to give me the average price for each car. Right? And it really gives you a price. I mean, these prices were, let's say, 20 to 30% off, but actually sometimes they were very close depending on how much data and how good the name is. But this was a feature you can just generate, right? And this took me, it took me a lot of time because I had to do it in a batch setting because the context size wasn't large enough. And it was expensive to buy ChatGPT Plus. But it works, right? And I think this is what you can take away from it, that really there are a lot of applications that we wouldn't have thought about before, that you now have just easily accessible, and it does all the things for you, and it actually already is this kind of automated data science agent, because internally it calls Python. So what you can see here, if you ask it this question, it just calls Python in the backend and shows you even the Python code it uses to generate this response. Right, so it's all automated already. Now in a more automated way, we have this context of automated feature engineering that Frank already mentioned in the morning session, where we can actually use a Python tool that talks to the LLM for us and does all of these things and generates new features and explanations, as you can see, for example, here. It generates, for example, age group and explains why, and you can go through and get the code. So we really already have some tools that can do this. They need to be fleshed out more, obviously, but it's not far away. All right. The hands-on that I'm just teasing here will be twofold. So I will have two collabs on the topic of automated data science or LLMs feature engineering. One is using Café, so the tool that we have developed, and you just plays around with it. And this will need an OpenAI key because you need to have like access to an API. So that's one downside. And then we have context-aware automated feature generation. So this is a bit of a smaller version of Café without the feature engineering part, just generating new features and explaining why. And there you can use different keys, but what I suggest is use Together AI. You can just sign up. It takes 1 minute and you get $5 for free, and you can use hosted APIs everywhere. Again, this will need a key, but it's really easy to get, and you can play around with it. And for reasons of, saving costs, these are not that long, so I don't want you to spend a lot of time. It usually costs like 10 cents if you would do this in a larger run, but for small models, it costs like 4 cents. All right, now to TabPFN. I think Frank already talked a lot about this in the morning session. Just a short reminder, it is a model we have pre-trained, and we essentially give it this new data here. That's the really interesting part for this hands-on, unseen real-world data, and let it predict this question mark part. And what I also want to highlight again is that it is really good compared to all other baselines that exist in our field. It outperforms them across the board, and is really a drop-in replacement for state-of-the-art models. So if you're using XGBoost, you can just replace the XGBoost call with TabPFN, and it's like the scikit-learn API, it works as well. And the current constraints are, at least in setting, to 10,000 samples, 500 features, and if classification, 10 classes. And also I want to highlight this plot, which I like a lot, is like the predictive behaviors, this double split experiment you might have seen in your physics education, that there's, you're trying to predict essentially this function here when I think photons are split in a very specific experiment, and we can use TabPFN or, for example, CutBoost to model the uncertainty of where these results lie, and we can clearly see that TabPFN is quite capable of modeling uncertainty correctly, so this is a regression task with uncertainty, while CutBoost with its quantiles and how you have to develop this in practice cannot do this natively and has therefore worse predictions that look a bit more messy. All right, and in the hands-on teaser for TabPFN, which I give around about 20 minutes, all you need is an email because we needed to have you sign up for an API, which then runs TabPFN on the cloud on a GPU for you. And it basically goes to classification regression, so you can look at this and compare to CutBoost and XGBoost, and then it analyzes the behavior of TabPFN for a few toy functions, so you can really see how it behaves in the decision space and classification. So in this top example, and here you will see what is the decision function TabPFN will build for this. And then you can see for regression how actually we'll model this certain logo down here, and how, so for example, other models like CutBoost might or might not be able to model ears. So that's the part that TabPFN hands-on will be on. All right, and these are the tiny URLs again. Feel free to go through them in any order you would like. I will walk around and answer any questions. Again, as mentioned, on the left side, we need for Café at least an OpenAI key because nothing else is supported so far. For KFG, I don't know. You need a Together AI, which is really easy to set up, takes 1 minute to register, €5 for free. And it is way more than enough you will ever need for the setting. And it will also be a really good idea to play around with these APIs anyways. Maybe as a final thing, I will just quickly go over it. So this is the feature engineering one, where we basically have, again, the setup and then just using this, and you will see later how this turns out. Here we have the Café demo, which is really similar to what you can find also in the README if you go on GitHub and just go through the example real quick and you can play around with it. And finally, this is the hands-on for TabPFN, which is longer and has more detail, which has predicting and has this predictive behavior, seeing decision boundaries, seeing the how it does regression, and also looking at like uncertainty and quantile regression, and finally at Batman. So that's the agenda. If you have any questions, please raise your hand, and I will be around. The time is over, so we have to close the session. I hope you enjoyed it. If you have any questions, feel free to reach out to us. We have an active team working on these tools. And also, if you want to contribute or participate in any of these things, let us know. We're happy to find people that want to work on this. And if you're interested in TabPFN, also let us know. All right, now.